this video, I'm going to be talking about how we can use tangent graphs. Now, in my last video, where we plotted the tangent graphs, I teased that this is a slightly easier process than it was for cosine and sine. Now, to add on to that, it's not particularly different, but it is just slightly easier because of the fact that it repeats itself every 180 degrees, and there aren't any repeats in the middle there. So with sine, it repeats itself even within the 360 degrees. There are two values where that sine theta repeats itself. Whereas with tangent graphs, we don't have that problem. So this does become slightly easier, but it's still basically the same idea. So to start off with, we can do the traditional reading off a graph. So if I look at this graph here, this is the tangent graph. I can use this to say what is tan of 300 degrees. So I find 300 degrees on my x-axis, which is here, and then I measure what that would be on the y-axis. Those lines are coming the wrong way around, never mind. And looking closely at that, it's between 1 and 2, looks approximately like 1.7. So we can use the graph in that traditional way that we do with all graphs. But we can also go in the other direction. So we can answer questions that look like tan of x equals something, x is between a and b, and I want to find what x is. And of course, as it was for the sine graph and the cosine graph, if we don't have this restriction here, there are infinitely many answers. So we do need to have some kind of domain. We need to have some kind of restriction to the values we're talking about. First step is going to be to sketch a tangent graph. Second step is to highlight the domain on our graph. Third step is to draw the lines, y equals c, and the lines going from the x-axis up to the graph. You're going to use your calculator to find one of the possible solutions. And then finally, we use the graph to find any other possible solutions. So this is exactly the same as it was for sine and cosine, apart from we've flipped out with tangent. The bit that's slightly easier, as it turns out, is this step 5, which I think is the hardest of the 5 steps. This is just slightly easier for tangent graphs than it is for the other 2. So we've got a question like this. Tan of x is equal to 5. And x is between negative 180 and 180. I want to find x. So the first thing I'm going to do is I'm going to sketch myself a tangent graph. Secondly, I'm going to highlight the domain we're talking about. So here we're between negative 180 and 180. So this is the domain we're talking about. Next, I'm going to draw on the lines, y equals c, and the lines going down from the graph to the x-axis, which looks like this. I'm going to use my calculator to find one possible solution. According to my calculator, inverse tan of 5 is 78.69. So that's clearly that solution there. That one there is the 78.69. So I need to use my graph to find any other solutions. Now, with tangent graphs, this is always going to take the same form. It's just going to be adding on or taking away a multiple of 180. Because it just repeats itself every 180 degrees, and that's the only way it repeats itself. So in this example, I'm taking away 180 degrees to get here. So I'm going to do 78.69, take away 180, and that's negative 101.31. So that's this value over here. So there is less thinking to do here, because it is always going to be add 180, add 360, add 720, or take away 180, take away 360, take away 720. It's always just going to be adding or taking away multiples of 180. So that's why the tan graph is just a little bit simpler. Have a look at another one. So we've got tan of x is 0.5. X is between 0 and 540, and I'd like to find x. So first I'm going to sketch a tangent graph. And I'm going to highlight the domain between 0 and 540, so this is the domain. And again, I know that that's exactly 540 because that's where we cross the x-axis. Draw on the lines y equals c, and the lines going from the x-axis to the graph, which looks like that. And oh, actually, you can see here we've got 3 solutions this time. We can have any number of solutions in theory. They normally ask you for only 2 or 3. So in this case, we've got 3. I'm going to use my calculator to find one of these solutions. So inverse tan of 0.5 is 26.57, so that's clearly that solution there. And then I'm going to use my graph to find any others. So the first one is just going to be 180 plus 26.57, which is 206.57. And then this other solution here is just 360 added on to 26.57, because it's 2 lots of 180, which is 386.57. So hopefully you can see this is just a little bit quicker. Okay, we've now got 3 tan x equals 13, and x is between 90 and 450. I want to find x. So firstly, I'm going to sketch a tangent graph. Then I'm going to highlight the domain. Then I'm going to draw on the lines y equals c, and the lines from the graph to the x-axis. Then I'm going to use my calculator to find inverse tan of c. Now, of course, because this is 3 lots of tan x equals 13, then tan x is 13 over 3. So that's actually the value I'm after. That's my actual c here, is 13 over 3. So inverse tan of 13 over 3 is about 77.01. Oh, but that solution isn't in our box. That solution's over here. So that's not one of my answers. But I can still use that to find the 2 answers that I do need. Because I can use the graph to find the other solutions. I can see that this solution over here is 180 added on to 77.01. And these are coming out in completely the wrong order now. Sorry for that. And this one here is 360 plus 77.01. There we go. So we've got 77.01 plus 180 to give us this solution here, 257.01. And over here we're adding on 360 to give us 437.01. Right. What we also had for sine and cos is some kind of identity, some kind of algebraic way to work this out that I still don't advise you use, even though with tangent it is slightly easier. If we add on or take away any multiple of 180, we're just ending up at the same value. So tan of x plus or minus 180 is just tan of x. And if we're going negative, so tan of negative x is just negative tan of x. That should be a negative. Let's change that. Should be negative tan of x. Okay, so the key points from this video. We can use the tangent graph to find approximate solutions to equations involving tan. Equations of the form tan of x equals something have infinitely many solutions, so we normally need to specify a domain. If our calculator gives us one solution, we can use a graph to calculate any others, and this turns out to be slightly easier for tangents. And then the same thing can be done algebraically using the tangent identity.